Alrighty, so now we're looking at depreciation. Now previously we looked at simple interest where the amount grew, was positive. Now we're looking at where the principal or the initial amount is actually decreasing, alright, so it's negative. So let's dive into it a little bit more. So depreciation is the loss of value of an asset, so that might be something we own like a house, a car, a surfboard, a football, anything. Right, so the loss of value of an asset is called depreciation. Right, the value is going down, it's decreasing. Over time, the value of a large item gradually decreases. So a car bought new this year will not be worth the same amount of money in a few years' time. Right, it's going to depreciate. There are two types of depreciation that you need to know. There is flat rate depreciation and there is unit cost depreciation. Right? And we can model these using a linear decay recurrence relation. We're going to learn about those now. The first one we're going to look at is flat rate depreciation. So flat rate depreciation is very similar to simple interest, but instead of adding a constant amount of interest, a constant amount is subtracted to decay the value of the asset over every time period. Right? So instead of increasing in value, it's going to decrease in value. So the following recurrence relation can be used to model flat rate depreciation. So we've got VO, our initial value of the asset, and then the rule. So VM plus 1 is equal to the current term minus D. You remember in interest, we've got plus D. In depreciation, we've got minus D. All right, so VN will be the value of the asset after a certain number of years, and R will be the percentage of the depreciation rate using the same formula that we used for simple interest, except now we're subtracting that. So let's have a look at this example. So modeling a flat rate depreciation with a recurrence relation. All right, so here's the example. A new car was purchased for $24,000 in 2014. The car depreciates by 20% of its purchase price per year. It says model the depreciating value of this car using a recurrence relation of the form. VO is our initial value, then our rule is VN minus D, where D is equal to R over 100 times the initial value. Right, so firstly, what was our VO, our initial value? Well, it was 24,000 as it said in the question. Now to find D, we take the rate, which was 20%, divide it by 100, then times it by VO, which was 24,000, and from that we will get 4,800. Remember, you can just do that in your calculator. Alright, so writing it in the form of a recurrence relation, we are left with VO is equal to 24,000, and then our rule, VN plus 1 is equal to VN, current term, minus, different to simple interest, 4,800, which was our D. So there's that one there. Nice. The next part of the question says, use the model to determine the value of the car after 2 years. Do this using your CAS. Now you can always do this using your calculator. Alright, we've done some videos on that previously. If you're unsure, see the sequences. There's a video at the end of that in those notes. But what you need to do is first you need to type your initial value and press equals. Right, remember that our initial value is 24,000. There it is. Once you press enter, then you're going to subtract D, or the amount that's depreciating by. So you're going to go minus 4,800, and then you're going to click enter. And that is going to bring up your value after 1 year. Press enter again. 2 years, press enter again. 3 years, press enter again, and you get 4 years. The second type of depreciation that we're looking at is unit cost depreciation. Right? So some items lose value because of how often they are used, right? Rather than because of their age, like a car or a house and things like that. Unit cost depreciation can be used on things like a photocopier. So for every few prints, or a lawnmower, maybe on how many uses it's had. Now, the recurrence relation that we use for unit cost depreciation is and looks the same as our flat rate depreciation. The significant difference is that D, instead of D being found using R over 100 times our VO, D is simply just the cost per unit of use. For example, a photocopier may depreciate by $10, right, per 1,000 copies, let's say that. I don't know if that's true, but it's around that. So rather than calculating the rate, we just know that D is equal to $10 per 100 copies. Let's have a look at an example. Alrighty, modelling unit cost depreciation with a recurrence relation. So, a professional gardener purchased a lawnmower for $270. Must be an alright lawnmower. The mower depreciates in value by $3.50 each time it's used. That is a lot of money for each use. Alright, model, so A says model the depreciating value of this mower using the recurrence relation of the form. Alright, like we discussed previously, VO is equal to the initial value of the asset, and our rule is equal to the current term minus the difference. Remember, D is per unit of cost. We're not using R over 100 times the initial value. It's just per unit of cost. Let's write out the recurrence relation. So VO, it was equal to 270. All right. And our rule, Vn plus 1 is equal to Vn minus D, and that was $3.50 per use. So there we have it, our recurrence relation to model this unit cost depreciation. Alrighty, so this next part, B, says use the model to determine the value of the mower after it has been used 3 times. Alright, now we can do this using our Casio, and that's what I recommend, but I'm going to show you how to model it here. Alright, so V1 is going to be calculated by the current term minus $3.50. So let's write that out. We've got V0 minus $3.50. V0 was $2.70 minus $3.50. We get $266.50. Awesome. Just a little note here. When we're working with money, we always write it to 2 decimal places, right? Never more, never less. And when we're working with $2, the 2 decimal places, if we get, say, 57 cents, so $2, $20.57, it stays as $20.57. You don't round to 55 or to 60, right? It stays as $20.57. Anyway, continuing on. To find our second year, it's going to be the current term. So V1 minus $3.50. Should be starting to see the pattern now. V1 was here, which is $266.50. All right, minus $3.50. There, we're going to get $263. Finally, we're looking for the third year after it's been used 3 times, rather, not years. After 3 times, we're going to go V2 minus our difference, which is $3.50. Alrighty, and we get V2 is 263 minus $3.50. We are left with 259.50. Right, so it has a value of $259.50 after its third use. Nice. Remember, you can do that in the Casio on your calculator. Alright, finally, C. How many times can the new mower be used before its depreciated value is less than $250? So that question's a very common question that you're going to see. How many times can it be used before its depreciated value, its value is less than 250? So we're looking for the last use before it is less than 250. Use the instructions below on your calculator. Easiest way to do that. Have a look.